today we will be solving these questions now about enthalpy change. Before that, oh, I discussed this as well with you guys. Do you all remember this part or no? All of this. Bond breaking and bond making. Do you all remember? Okay, that's good. So the formula for enthalpy change is what basically all you need to do is find the change in energy that has occurred that will provide you the enthalpy of that particular reaction. So for example, see over here, the total energy needed minus energy given out will give me what? My enthalpy change. Now, I discussed about the convention of the signs as well with you guys. Let's revise it again. See over here. Exo means bond making. Endo means bond breaking. We have to memorize this and we have a mnemonic for it, and the mnemonic for that is mexo-bendo. Do you see this written on your screens? Here it is. So what does mexo mean? Mexo means making of bonds, that means bond making, and it is an exothermic reaction. And the other part was bendo. Bendo means what? Breaking of bonds, and it is an endothermic reaction. So how are bonds made over here? The energy is released through to the surrounding, and this is where we get in the product part. We get the energy over here. Over here we have a bond, and endothermic reaction breaks the bond basically. So this was a bond. It received energy. Energy was received from the surrounding to the reaction over here, and this in turn helped in breaking this bond between A and B, and we got this. Easy, you'll get this part. So do not forget this mnemonic, the mexo-bendo. This will be very useful for you all. Now let's move on to our next slide, that is the activation energy part. But before I start with the, oh yeah, we can start with the activation energy. Yes, let's start off with the activation energy. First of all, let's talk about the definition of activation energy. So what actually is activation energy? The minimum energy required to start a chemical reaction. For a reaction to take place, the colliding particles must possess at least this amount of energy. What do they mean by this all? What they are trying to say over here is that for any reaction to occur, we need energy in them, then only they will react with each other. If there is no energy between them, then it will be not possible to get the desired product. So there is this thing called activation energy. It is the minimum energy that we need for a chemical reaction to take place. Do you all get my point? Usually what we do is heat to our reactions, to the reactants, and by providing heat they gain energy, and through that energy they start reacting with each other and provide us the product. Got my point? Any questions so far? Alright, let's have a look at this pathway diagram now. Before, the pathway diagram looked like this. It went straight all the way down and then like this. This was the downward arrow. Here was my reactant. Here was my product. The downward arrow was representing that we are having a loss of energy, which means it was an exothermic reaction. Right? Now over here, what they are trying to tell here is that we need a very small amount of activation energy for this reaction to take place. This reactant was over here before, but they were not reacting with each other because they did not have the minimum required energy that was needed for the reaction to start. So therefore, here this part, this curve that you see, this curve, this is the activation energy part. This could be asked in your MCQs about how or where is the activation energy, how much is the activation energy. So do you see this peak over here, from here all the way till this point? This whole part represents your activation energy. And then the enthalpy of the reaction. This part is representing how much energy we are using, and that is providing us the product. So if you want to, for example, find the enthalpy change, then what would you do? You will simply find how much energy is used over here. That will provide you the enthalpy change. If you want to find what is the activation energy needed for the reactants to start reacting with each other. So in the graph here, all the values will be written on the left hand side. So this is the value part that you will have to notice how much this part is. That will provide you the activation energy. Now, how would I know that whether the reaction is an endothermic reaction or an exothermic reaction? Like I told you before, in an exothermic reaction, the reactant's energy is always more than the energy of the product. And in an endothermic reaction, the product's energy will always be greater than the energy of the reactants. So have a look at these two pathway diagrams. See over here. It is an exothermic reaction. Why? The energy of the reactant is less than the energy of, or is greater than the energy of the product. How is this an endothermic reaction? See, the energy of the reactant is less than the energy of the product over here. So, will you all be able to properly understand these pathway diagrams if they are asked in your paper? Okay, very good. So, all of this over here, no, not all of this, 1 minute. This part is what? The activation energy part. This part is my enthalpy change part. In the same way, this part till here, this is the enthalpy change part, and this here is my activation energy part. So you must be well aware about all these curves and all these pathway diagrams. Then it will be very easy for all of you all to solve the questions. Any questions so far? Okay. The chapter is almost over. We'll be starting the past papers soon now. I'll just take you over here to this other page in case we have left something that I haven't discussed. Let's have a quick review all over again. So, exothermic reactions. What is an exothermic reaction? This is the definition that you all properly have to memorize. The exothermic reactions give out energy, so there is a temperature rise, that is, heat is given out. If they ask you to represent an exothermic reaction through an equation, this is how you would represent. The energy is always where? On the product side. The energy is always given out. And if they ask you to show the energy level diagram or pathway diagram of an exothermic reaction, this is how you would draw that diagram. Properly memorize these points if they ask you for examples of exothermic reaction. Like I discussed before, heating of wood, burning flames, neutralizing acids by alkalis, the combustion of fuels when we burn fuels, and even when we are respiring. So the respiration in our body cells is also an example of exothermic reaction, because in all these reactions we are giving off heat in the environment. Then in the same way, what's endothermic reaction? The reaction that takes in energy from the surrounding. What are the examples? Like I told you, the melting of ice is an example of an endothermic reaction. There are some more examples that are written over here. As you can see, barium hydroxide reacts with ammonium chloride and the temperature falls. So remember, whenever the temperature is falling, it is an endothermic reaction. That means heat is being absorbed from the surrounding. How would you represent an endothermic reaction through an equation? The energy part is always at the reactant's side. Okay. This part. This is the important part, yeah. Now I'll teach you how to basically find the values, how to find the enthalpy change now. Let's try to solve this numerical. Have a look at this first example now. What are they telling us here? The exothermic reaction between hydrogen and chlorine. This is the diagram. Okay, in the paper, you will only be provided this diagram and then they will ask you to just find the enthalpy change. How much is the enthalpy change? You will have to do all this work all by yourself, all of this. So let's see how it's done. First, let's have a look at this part, at the energy diagram or the pathway diagram. We see that our reactant is what? Hydrogen and chlorine gas. Both of them are reacting with each other and providing us HCl. I can see that this is my reactant and this is my product. As you can see, the reactant's energy is higher than the product's energy. What does this represent? It is an exothermic reaction. Are you all with me till here? Okay. Now, what does the question say? How do we find enthalpy change? The formula for enthalpy change was energy in minus energy out. How much is my energy in? Now, this part will be provided in your paper. Most probably, they'll write down these values like this for you guys. Over here, they would write, for example, 678 kilojoules here, or here they would write 678 kilojoules. And in this part, they would write what? Energy out. The total energy out. This whole thing is what? How much it is? This is the activation energy part. Do you see this part? The bond is broken over here. Energy is taken in over here. They won't write it here like this. The total energy required for these two to react with each other was how much? 678. And the energy that was taken out was how much? 862. 862. Here it is. How do we solve this question now? Let's see. I'll tell you how do we calculate this and how do we calculate this. You will have to calculate all these values all by yourself. See now. We have two molecules of hydrogen. We have two molecules of chlorine. And in turn, they are giving me HCl. And when we balance this equation, I'm going to write 2 over here. All these things are very important to write down because these will help you make down the whole energy level diagram basically. So see. Okay, one more thing. The energies will be provided to you guys in the exam. So I'll show you this part. On page number 116, I'll show you what is the energy. See this part. This is the important part. How much energy does hydrogen-hydrogen bond have? Can you see? 436 kilojoules per mole. This is the bond energy of a hydrogen-hydrogen bond. What is the bond energy of a chlorine-chlorine bond? It is 242. I will be needing only these two, not the rest. Oh, I will be needing this as well, HCl. The bond energy for this is 431. So let's write down these values because we will be needing these values to get the answers. So hydrogen needs what? 436. What is chlorine bond? It is 242. How much is HCl? It is 431. Now see how we use these values. How many hydrogen bonds do we have in the equation? Can you all tell me quickly? Here. So we have only one bond over here that is of hydrogen. So see how do I write it down? I'll write 1 multiplied by hydrogen bond. What was the value of my hydrogen bond? It was 436, correct? So I will multiply 1 with 436. This is already balanced. This equation over here is balanced. If I had written, for example, 3 over here while balancing, then what would have I done? I would have multiplied 3 with 436. Do you get my point? Okay. Okay. What about chlorine? This is also a single bond. I don't have any number written over here. So I'll be just simply multiplying what? 1 with the chlorine bond. How much is it? It is 242. So I'll write 242. Now these two are going to react with each other. Therefore, I will be adding these two bonds together. That would give me the total energy. That is what? 678 kilojoules. So what did I get through this equation? I got to know how much energy is being used over here. That is 678. This is the energy in. This much energy is being used up by them. Then they break the bond. So this is my energy that they will need to break the bond. That means this is energy in. It means it is the endothermic part. Do you So energy in means what? Remember? Try to remember what was the mnemonic. You'll remember the mnemonic. Or you mean Nexo bendo. Remember? Okay. So nexo means what? Making of bond. So bond making is over here. Bond breaking is over here. Energy is taken in this part, energy is taken out in this part. When we are giving an energy, that means it is endo part. When we are giving out energy, it means it is the exo part. So the reactant side energy that I have found, this is my energy in. Now I need to find the energy out part. What do I have in the energy out part? See, 2HCl. How much energy, how much bond energy does HCl have? It is 431, as you can see over here. And we have balanced this equation. Therefore, we have 2 over here, and hence I'll be multiplying 2 with 431. That would give me what? 862. This is the energy out part, as you can see. Now what do we do? Once I have my energy in and energy out value, I need to find the change in energy. This is the formula that you would always need, energy in minus energy out. Solve it and you'll get the answer, that is 184 kilojoules. Now, do you see this negative sign over here with the answer? Yeah? Okay, so when will you put this negative answer? Whenever my reaction is an exothermic reaction. See, in an exothermic reaction, the reactant's energy is greater than the product's energy. In an exothermic reaction, we will always represent it by a negative sign. The exothermic reaction will always be represented by a negative sign. Okay? This would show that this energy is given out. Any questions over here? This minus sign is indicating that it is an exothermic reaction and the energy is being given out. Because in the diagram we can see that the energy of the reactant is more than the energy of the product. Okay? Now let's have a look at another equation over here. This is for an endothermic reaction now. See over here, the energy of the reactant is what? It's less than the energy of the product. Just by looking at this diagram, I can clearly tell quickly that it is an endothermic reaction. And in an endothermic reaction, we represent an endothermic reaction with a positive sign. That means the energy will be taken in, it won't be given out. Now let's find this part. See this part. 2NH3. 2NH3 means 2 multiplied by the bond energy of NH3. Now let's find the bond energy of NH3. Where is it? Here it is. What is the bond energy between NH? 391. Where is it? Here it is. Okay. So this was NH3 and I just showed you that it is 391. So how do we solve it now? See. This part first. Look now. Energy in to break the 2 moles of bonds is how much? How many bonds of nitrogen and hydrogen do we have over here? Can you all tell me why do we have 6 over here? This is my question. Now see this part. What are they telling us here? They are saying to break the 2 moles of bonds, we will be multiplying it by 6. This is the most important part. See how will you do this. This is one NH bond. This is the second NH bond. This is the third NH bond. Did you get this point? Yes or no? Yeah, okay. So this is how I got 3. Okay. See, first NH bond, second NH bond, and third NH bond. These are the 3 bonds, and then we have 2 written over here. So it becomes 2 multiplied by the 3 NH bonds. So it becomes what? 6. So it is in total 6 NH bonds. Before it was written what? It was written like this, NH3. Instead of this is how I break it down into first. So that my equation becomes easy. And then I simply write 391 in place of NH, and I get 2346 kilojoules. Any questions still here? Okay. Let's move on now. See this part. Triple bond of Nn. How much energy does it need? 946. So I'll write simply 946 here. In this place, 3 multiplied by hydrogen bond is what? 436. So energy in part is this one. This over here is my energy in. How much is the energy out? It was very simple. 1 mole of Nn bonds, triple bonds, and 3 moles of hydrogen bond. That gives me 2254 kilojoules. What is the formula? Energy in minus energy out. I simply subtract this value from this value. My answer is what? 92. The positive sign is representing that the reaction takes in 92 kilojoules of energy. Before it was what? Giving out 184 kilojoules of energy, as my answer was in a negative value. This was showing that it is an exothermic reaction. This here is positive, so it is representing that it is an endothermic reaction. Is all of this clear to all of you? All right. That's it. That's it in this part, this calculation part. Now, I'm going to send you a PDF. Did I send you in a chemical energetics PDF?